Start right now. So, good morning to everybody. Praise be the Lord. Now and forever. And now we
Now
want to,
forever.
thank you. Now we want to continue with this exercise. Do you have any question related with these exercises? Someone, but something that wasn't clear the last class? What I need is that you apply the properties as well. That's all that I need. Okay? More than conclude if the answer is right or not. No, it's just apply the properties. So, is it clear or not? Or what if this exercise wasn't clear for you? Which one? Okay, if there's no any question related with this one, you can send the questions in the chat, probably exercise A, probably exercise B, the C or the D. Be honest.
Mister,
Which one?
podría volver a explicar, pero así uno cualquiera completo. Es que la verdad es que no entiendo.
Okay, gonna apply the exercise, the C. For example, we want to see what this expression do, what 2 to the power of 3 do to that 27. If don't remember, there are some properties that help you to understand what happened with this. For example, this property that help you to understand that fractional exponents at the end are hidden, or yes, are hidden a root expression like that one. And for example, if I have 4 to the power of 1/2, 4 to the power of 1/2 is the same as you have the square root of 4 to the power of 1, according with that property, okay? Or if you have it like 4 to the power of 3/2, is the same as you have the property like this, square root of 4, but because this is not 1, this 3 is not like the one we have in here, we should write it like that, okay? So that's the property we want to apply, that's all. And we will see how to do it in this exercise. It's clear now, the property we're gonna use?
Yes.
Yes, so that's what we want. Then we're gonna use this property, which is like the reciprocal of this one, is apply the property in other way or like backwards. So we're gonna concentrate in that example C that you asked me to solve. It's okay, example C. It is 27 at the power of 2/3. So it's gonna be the cubic root of 27. And because that one is not 1, this 2 is not like the one we have in here with the 8 or with the 4 I show you. It's gonna be then to the power of 2. It's okay. So how can you solve this one? You have to get the square root of 27. So how can you get that very quickly? All that you have to do in order to make this easier is decompose the 27. I think you know how to decompose these numbers or not. Do you know how to decompose the numbers or not? Do you know how to decompose the numbers or not? Here, like if it's divisible by 2, no, it's not divisible by 2. It's divisible by
If it
3.
is
By 3.
divisible by 3.
Excellent, which is 9. Then it's divisible by 3, which is 3, and it's divisible by 1. So what means these? It means that 27 is the same as you have 3 times 3 times 3, or 3 to the power of 3. What does implies? It implies that the third root, which is, what is the third root of 27? Is look for one number that multiplied itself 3 times, okay? What number multiplied itself 3 times gives you 27? Don't say that you don't know it. Here you have the answer. 3 times 3 times 3, it's going to be 27. So what number multiplied itself 3 times gives you 27? 3. That's why the cubic root of 27 is just 3, okay? So we solve the part inside of the parentheses. That's why here is gonna be then 3 to the second power. And then what is 3 to the second power? 9. 3 to the second power is 3 times 3. Okay, and that way we can conclude the answer here is 9. Clear
Mister,
now?
that can be known also as a cubic root or not.
Excuse me again?
I mean, if the when the 3, when the 7, when the no, yeah. My question is, does that type of root can be known as a cubic root or not?
Yeah, this is a cubic root. This is a cubic root, okay? And 27 has an exactly cubic root. Differently than 4, 8 has a cubic root too. 64 doesn't have a cubic root. So how can you know that if it has or not decomposing the number? Okay, so I think you're clear, and now we should go and apply other properties. We have more properties. These two other properties will help us. This one, for example, tell us that if you have the product of one expression inside of a root, then you can separate those into different products. Like, for example, this. The square root of 4 times 9. You can write it like the square root of 4 times the square root of 9. And that way conclude the answer quickly, which is 2 times 3. That's going to be 6, okay? Something similar in here, the square root of, what about the same expression? 4 over 9 is the same as you get the square root of 4 and then the square root of 9. I mean, can you get the square root of 4 over 9? No, but if you get it if you get it separate, then you're gonna conclude quickly the answer, 2 over 3. What about that one? That one's the most important property, and it's related with what we did. For example, the cubic root of 27. We said the cubic root of 27 is 3. Reason is 27 cubic root, 27 can be written like 3 at the power of 3, okay? Which, applying this property tells you that practically if you have a power and an index and a root like the same number, they can cancel each other, and that's gonna be just like 3, okay? So these ideas are very important, and this is what we want to apply in order to solve, to simplify, some exercises. Then the simplify exercises with roots will be just simplify fractions, you will see. So here we have 3 exercises, and I want that we apply the properties in these 3 exercises, starting that one. For example, here, what property can we apply? We can apply the property that we have in here. We're gonna move those better to the whiteboard. That way we're gonna solve this more organized, I think. And as you can see, this one fits this property, this exercise, fits exactly in that property, as you can see that one. The second one, okay? And we're gonna use it. So there he is. So how can we simplify the cubic root of x to the power of 9 over y to the power of 3? Very simple. First thing, we should separate the cubic root for each expression, okay? Look, what I need, to be honest, is just that you apply the properties as well. What property can we apply in here? Do you remember what property can we apply in here? Because this expression requires that you simplify. To simplify expression, you must consider that this exponent have to be less than this index. So right now it's not simplified because that exponent is greater than that index and is not properly to work with that expressions. So if you don't remember, there are some other properties we studied. I'm talking about these ones, for example, that will help us to solve that exercise right now. Right now we have the expression like this. So then we want to write it like that. And like I told you, simplify expressions with root will be just simplify fractions at the end. So this expression in here will be x to the power of 9 over 3. If you remember, properties next one. The n root of x to the power of m is the same as you have x to the power of m over n, okay? And that way you conclude like the answer of that expression over. Here you can apply other property, is one of the ones that I told you. Who can tell me what's the answer of that one? Using specifically this property here, the third one. Specifically that property here. I mean, y to the power of 3, the third root of y to the power of 3. Someone said that in the chat, let me see. It's just gonna be y. You're right. It's just gonna be y. So here is just gonna be y. Now, if you see, we can simplify that fraction, 9 over 3. It is divisible by 3. Both are divisible by 3. So then we have 3 over 1, which is just 3. So the expression here at the end is just x to the power of 3 over y, and you already simplified the exercise, okay? Something similar will happen in that one, but that one requires something interesting, okay? And I think that if you don't get it, don't worry about it. What matters for me is that you apply those properties, okay? So I'm gonna write this exercise in here. The fourth root of 32 x to the power of 8, okay? And here we're gonna do the same. We're gonna separate fourth root of 32 times the fourth root of x to the power of 8. You should consider next. If you see 4 and 8 are multiples one another, okay? They are multiples of the same number. It means that like in this case, they will be simplified. I'm saying this because in one exercise, in the last one, something different will happen. And what is the fourth root of 32? We will look if 32 has an exactly fourth root. How can we know that? Decomposing the 32. So help me. Participation here, please. 32 is divisible by?
2.
By 2. So it means that it have a half. The half of that is 16. 16 is divisible by 2. 2 is 8. Now, 8 is divisible by what?
2.
By 2 again, and the half of that is 4. These have a half too, which is 2, and these have a half, which is 1. So it means that we can write 32 like 2 times 2 times 2 times 2 times 2, 5 times, right? So this essentially is 2 at the power of 5. Okay, 2 at the power of 5 doesn't fit on this, but if you have 2 at the power of 5, then you have 2 at the power of 4. I mean, because we're working a fourth root, and the same happens if you work a third root or on a square root, but in this case that we're working a fourth root, we want to group these twos, this bunch of twos, in groups of 4. And here we're going to have 2 at the power of 4 times 2, okay? So instead of work with 32, we're going to work with 2 at the power of 4 times 2. Why? Because that way we're going to simplify something. The idea of these expressions is just simplify. So here we go. And here we have the fourth root of 2 to the power of 4 times 2, which is the same 32 we have in here, just that I decompose it like 2 to the power of 4 times 2. Why? Because then this 4 and this 4, they will cancel one and another. And now we're going to see what happened in here. So what property can we apply in here with this expression? Fourth root of x to the power of 8. Gonna screenshot this ones and move it to our page. We will see what property is useful. We're gonna copy that one. We're gonna move to another properties. Our properties we have related with this expression, these ones. And I want that you can use your marker, and tell me what property is going to be useful right now. What property is going to be useful in order to simplify that expression? What property? Here is the property. Here is the property that will help us to simplify this expression. So concentrate on this one. What property will help us to simplify it? Look for it.
Third one.
Which one?
The third one.
This one, right? Excellent. This is the one that will help us and is the one we want to use. Here is going to be, not now this expression, okay? Now is going to be x to the power of 8 over 4, like we did it in this exercise on the top. Of course, here now we should simplify. Here we have to separate and the fourth root of 2 times, and what is the simplification of that? I mean, you can simplify that expression. What is 8 over 4? Simplify it. It is just 8 to the power, it is just 2, right? Excellent. So that's going to be x to the power of 2. So then we have another property that will help us in here. Let me move the other properties we have over here. So what property can help us to simplify one expression in here right now? Of these ones. Specifically, what property can help us to simplify this expression in here? Is it that one?
The third one.
Is the third one, okay? I'm agree with you. Your analysis, it's okay. It's the third one. The third one will help us because you have same index and same exponent. This is just 2 times the fourth root of 2 times x squared. Okay, for me, matters that you identify what property is useful in order to simplify. More than simplify, because then we will see that topic like so on. I mean, looking the topic more deep, I mean, and we're gonna analyze why this expression behaves like that, okay? So don't worry if you don't get it right now, but then we're gonna concentrate on it, okay? Let's do the last exercise, and with this we'll finish today. Of course, here we're going to apply like the same idea we have been using. So we're going to see how this works. And we're gonna have the properties next to the exercise. That way we're gonna conclude it better. Of course, you should have all those properties in here. What matters for me again is that you apply these properties by the right way. So here we go. You can do something this exercise, and this for the first thing you should do is separate. Always when you have expressions like that one, you should separate. So here we have the cubic root of 24 times the cubic root of x to the power of 4. So what property tells you that? This one, okay? So you can apply the property, one property in one exercise many times. It's not just like one time. So here we go. And once we have this expression, we should look if 24 has an exactly third root. Does 24 have an exactly third root or cubic root? Yes or no? What do you think? 24 has an exactly cubic root?
Yes.
What is the cubic root of 24? Not agree? How do I know if it has an exactly cubic root? You should decompose the number like we have been doing it. So I'm gonna decompose 24 like, okay, 24 have a half, which is 12, have a half, which is 6, have a half, which is 3, and it's divisible by 3, which is 1. As you can, if you can see, it's a cubic root, right? It's a cubic root, means that we want to group these 3 by 3. So we're going to have 2 at the power of 3 times 3. This is the only way to represent that 24 too. There's no other one. And by that way, we see that 24 doesn't have like an exactly cubic root. Cubic root of 2 at the power of 3 times 3. Okay, times. And here we have similar problem. You can write this one like x to the power of 4 over 3, but then you will not simplify anything if you see, right? That's a little trouble. So what we should do? We should do something similar, and we should decompose x to the power of 4 with something that have power of 3 and something else. In that case, it's gonna be like that. Why is like that? Because you can decompose 4 like 3 times 1. And why like that? If you don't remember, when you multiply two expressions like that one, 3 at the power of, x to the power of 3. And x to the power of 1 will be x to the power of 3 plus 1, which is 4, okay? So here is like think backward. That's why for me matters more that you identify how to apply the properties, not like the exercise in essence. I mean, you will not solve exercise of simplify roots. No, I want that you understand how the properties work. That's all. And the only way to understand that is using it. So instead of work with x to the power of 4, we're gonna work with x to the power of 3 times x to the power of 1. Of course, everything that we have to do now is separate this expression. So we're gonna separate the third root, 2 at the power of 3, times the third root of 3 times the third root of x to the power of 3 times the third root of x to the power of 1. So I need your help, and I need that you circle the expressions that can be simplified. There are two expressions that can be simplified, and there are two expressions that cannot. That way we're gonna finish. Circle, please, the expression that can be simplified. You're able, that one can be simplified. It is just 2, excellent. Which other? This is cubic root of x to the power of 3. This is cubic root of x to the power of 1. No, that one cannot be simplified. I'm agree if you circle this one, look. Why? Because here is the property. Because of that, sorry, the other property here, I mean. That property, as you can see, that one, x, the nth root of x to the power of n. So it's like they cancel one another, and practically that's all that you can simplify. So final answer here will be x, and here cubic root of x. Okay, so we're gonna leave it until there. Again, what matters for me is that you apply those properties as well. You understand how they work. More than simplify roots, because that's gonna be a topic we're gonna study later, is that I want that we concentrate in that type of extras, in the properties we work, okay? So that is all for today. I think it is your last hour, so have a nice day, guys. I think I have to go to another class.
Thank you, Mr.
So bye-bye, and practice those exercises again.
Bye, Mr.
Bye, mister.
Bye, Mr.
Bye.
Bye, Mr.
No, Hugo.
Bye, mister.
Bye-bye.